All right, we got lesson 4.3. This is all about polynomials, the types, degrees, forms, addition, subtraction, so different things we can do with our polynomials and kind of identifying our polynomials. So some key terms first. First off, we have coefficients. I'm going to underline that one in blue. That would be all of these numbers in blue over here. Okay, it's just the number that's in front of the variable. So it means this number, like 6, is being multiplied by y. So y is the variable, 6 is the coefficient. It just means these things are being multiplied. Same thing with like 3h squared. It's 3 times the amount h squared, or h times h. So this one would be 3 times h times h. So coefficient, anytime you see a number that goes along with the variable. Polynomial is a monomial or a sum/difference of monomials. So anytime you basically have an expression. So just this 6y, this is a polynomial. It's just one term, so it's a certain kind of polynomial. It's a monomial. This is a polynomial, this expression, 4x minus 7. And how do we know that? Well, because 4x is a monomial, 7 is a monomial, 4x minus 7. So this monomial minus this monomial would be another polynomial. Right? This one would also be a polynomial for the same reason. So when each of these pieces is a monomial, and they're all added or subtracted together, that is what's called a polynomial. It's another way to say an expression. So again, each of these monomials are the terms. A binomial is a certain kind of polynomial that has 2 terms. So 2 monomials in it. So out of these 3, the binomial would be this middle one, the 4x minus 7. It has 2 terms, or 2 monomials, the 4x and the 7. So these two together, 2 different terms, this would be a binomial. Think bi as in bicycle, has 2 wheels. So a bicycle binomial has 2 pieces. In that case then, a trinomial, think tricycle, would have 3 pieces. So that would be this one here. Again, these are all polynomials. Poly meaning many. So that's just kind of a prefix meaning there could be a lot of terms. It's many terms as we want to call it. These ones are specific. Binomial, 2 terms. Trinomial has 3 terms. This 3h squared plus 6h minus 2. 1, 2, 3 terms. That would make it a trinomial. The degree of a polynomial is the greatest degree of any term in the polynomial. We'll get more into that one later. In each of these cases, though, this one we'd say is a degree 1, because this y is like a hidden to the first power. 2, or this one here, the second one, x is to the first power, so this is also a degree 1. This one, we have something to the second power, so we would call this one a degree 2 polynomial. And we'll get more into that in some of our other examples. Standard form of a polynomial. All of these ones are already written in standard form. Basically what that means is we're written so that the terms are in order from greatest degree to last, or least degree. So any constant like this would be a degree 0. There's no variable with it. And if there was, you can kind of think of it as, let's say it was x to the 0th power, because anything to the 0th power is just 1. So it's like we don't even need to include that. So this is x to the first power. This is an x to the 0th power. So we would say that the degrees 1 and 0, degree 1 comes first, degree 0 comes last. So that would be a standard form, just writing each term in order of their degrees. And leading coefficient, it's the coefficient of the term with the highest degree. So in a case like this, there's only one term, so our leading coefficient is 6. In one like this, well, I guess there's 2 terms, but the x has the highest degree, x to the first power, so 4 is our leading coefficient. In this one, 3 is our leading coefficient, because this term has the highest degree. It's an h squared. So looking over this chart, degree of a polynomial, if you can call it a constant, so something like just this 5, that would be a degree 0 for the same reason we went over. It's like 5 times a variable to the 0th power, so it's a 0 degree. We would call that kind of term a constant. If the term just has a variable with kind of a hidden to the first power, so nobody mentioned that there's a power here, so it's kind of assumed it's to the first power. It's just x by itself, 1x there. That would mean that the degree is 1, and then it's a linear term. So if we were to call it one whole polynomial, so if I were to take like a add here, so if this were our polynomial, we had 2x plus 5. This whole polynomial is a degree 1, and it's called a linear polynomial. And it kind of makes sense because one of these, if we called y equals this, y equals 2x plus 5, that would be a linear function. That would make a line. 5 would be our y-intercept, 2 would be our slope. So we can make a line out of that. It would be a linear polynomial. Put those back. If we have a term that has something to the second power, that would be called a quadratic term. So like 12g squared. That makes a quadratic term, or a degree 2. So again, if we were to make a whole polynomial out of something like that, so like 12g squared plus 2x. This one is a linear term. This is a quadratic term. The highest term, the highest piece of this is a degree 2. So the whole polynomial is called a quadratic polynomial. Move those out of the way. Next one, cubic. If we have a degree 3 of the whole polynomial or just one term, it really only needs to have the one term. So something like 3r to the third power. Or if you separate it out, so 4c to the first power, d to the second power. This term, this 4c to the first, d to the second, we have to add the exponents together to find the degree of this term. So this one would actually be a degree 3 because 1 plus 2 is 3. So it's actually kind of two ways to find the degree of a term. It's either the highest of just the one variable or add up all of the exponents of the variables. Okay, so these would both be called cubics. They are both degree 3. Same thing for quartics or degree 4. Things like 9h to the 4th because it has the h to the 4th power. That's a degree 4. Or if we had 5j squared k squared, 2 and 2 add up to 4. Or 13q to the first power, w to the third power, 1 and 3 add up to 4. Okay, so you could have like 3 different variables behind this, and they all of their powers add up to 4. That would be a quartic term, and if that was the highest degree term in that polynomial, it would be a quartic polynomial. Same thing with quintic, degree 5. You could have something like 4f to the 5th power. So that term itself would be a quintic term, and if that's the highest degree in the whole polynomial, your polynomial is called a quintic polynomial. So the highest degree term determines the whole polynomial. So those would be kind of our rules for defining those. So a couple examples here. Determine whether each expression is a polynomial. If so, identify the polynomial as a monomial, binomial, or trinomial. So first off, I want you to cross this piece out. Spell check didn't catch that. These are not polygons, these are polynomials. So rules for polynomials, just like our monomials, there can be no variables in the denominator and no variables to a negative exponent. Okay? The difference between polynomials and monomials is polynomials. That poly, remember, means many. Poly means many, so there can be as many terms as we want. So there can be addition and subtraction in between our pieces. So let's see what a couple of these look like then. A, we have 4y minus 5zx. Okay, that one, yes, that would be a polynomial. Okay, notice how we have that minus in between them, so we have one term here and a second term here. So that one we would call a binomial. There are two terms making that up, so it is a binomial. negative 6.5. Okay, this one doesn't have any variables, so this is just a constant, or it's a degree 0, but there's only one term. So yes, it is a polynomial. What kind? It is a monomial. Just one term makes it a monomial. Looking at C, we have 7a to the negative 3 plus 9b, and it's all by itself, so it's kind of a hidden b to the first power. So would this one be a polynomial? Actually, we'd say no, because it has a to the negative third power. We would say there's a variable with a negative exponent. So no, this one would not be a polynomial. Looking down at D then, we have 6x squared plus 4x plus x plus 3. First off, on ones like this, we need to combine our like terms before we can do anything else. We have 4x and x. Those ones we can combine together and make it a 5x. So this would be 6x squared plus 5x plus 3. So this one, although before there were 4 different pieces, we can combine these into just one piece, these two. So it would be 6x squared plus 5x plus 3. And yes, this one has 3 different terms, but each one is a monomial on its own, 6x squared, 5x, and 3. Yes, this one would be a polynomial. It's a trinomial, 3 different pieces. For E, we have 4s cubed divided by x. We would say no. There's a variable in the denominator. We have an x right here, so this one would not be considered a polynomial. And for D, we have negative 3y squared minus 2y plus 1. Again, we've got 3 different terms, negative 3y squared, negative 2y, or this, minus this 2y, and 1. This one is a constant. This one is a linear because it's y to the first. This one is a quadratic term because it has y squared. 3 kinds of terms, quadratic, linear, constant, would make it a trinomial. Yes, it is a polynomial. It is a trinomial because there's 3 different kinds of terms. So that would be identifying our polynomials. Okay, now we're going to look at the degree of a polynomial. How do you find the degree of a certain polynomial? And I'm going to write in here something to remember. Add up the exponents, of the variables. Remember, you can just add up the exponents of the variables in one term. That would be the degree of each term, and then the highest degree, degree term would be the degree of the polynomial. So if we look at this polynomial, it is a binomial. We have one term here and one term here. This term, 9, is a degree 0 because there's no variable with it. This term is 6a squared b cubed. Well, 2 plus 3 make it a degree 5. So which one is the highest? Obviously it's the 5. So we'd say it's a degree 5, or we call it a quintic. This is a quintic polynomial. Quintic term, constant term, is a quintic polynomial. Let's look at this one. We have 3 different terms. 8d to the 5th power minus 12c cubed d to the 4th minus 7. This 8d to the 5th power, well, there's only one variable, so it makes it nice and easy. We just say it's degree 5. This term, we have c to the 3rd, d to the 4th. 3 plus 4 is 7. So this one is a degree 7. And in this term, 7 is all alone. There's no variable, so it's a degree 0. So which of these is biggest? Again, obviously we see the 7 is the biggest, so we just call it a degree 7. And at that point, anything after 5 we don't really have names for. Quintic is our highest degree that has its own specific name. So this one we just call it a degree 7 polynomial because we have a degree 7 term in it. Let's look at C. We have 9ab to the 4th c. when you come up to ones like this where they don't necessarily have the power written next to the variable, go ahead and write in that they're to the first power, c to the first power, a to the first power. If it's just a on its own, there's only one of them being multiplied. So it's a to the first power. B to the fourth means b times b times b times b. There's four of them. That's why there's a 4 there. And again, just c alone means there's one of them there. So c to the first power. So we've only got one term, all of these things being multiplied together. So we just, again, add up the exponents. 1 plus 4 plus 1 becomes 6. So this one is a degree 6 polynomial. Specifically, one term, it's a degree 6 monomial. For this last one, for D, I want you to pause the video and try this one on your own. Take a few seconds. Again, look at each term, look at each piece of this polynomial, add up the exponents of the variables, and find the degree of each term, and then say which term has the highest degree. That'll be the degree of the polynomial. So I want you to take a second, pause the video, and try it on your own. So at this point now, after you got it, we're going to check, make sure you got it correct. We've got one term, two terms, three terms, and four terms. We can tell because each one is separated by an add or subtract. We have 2 RT. Remember, each of these, R is to the first power, T is to the first power, 1 plus 1, 2. We have a second degree polynomial, or second degree term right here, minus this 3 RT squared. Remember, R is to the first power, 1 plus 2, this is a degree 3, plus 11, R to the third power, T to the second power. 3 plus 2 is 5. That's a term to the 5th degree. And minus 13 alone with no variables, so it's a degree 0, or just a constant term. Again, obviously, which one of these is highest? 5. So we'd call this a 5th degree, or degree 5 polynomial, or you can call it a quintic polynomial. So that would be our degrees of polynomials. Last piece, writing each polynomial in standard form. Then we need to identify the leading coefficient. So remember, when you write the polynomial in standard form, you're just putting the highest degree first. So I'm going to write that right here. Highest degree to lowest. Okay, so as we look at these, we've got 4x squared, 9x to the 5th, and 7x. This one is a degree 2, x to the second power. This is a degree 5. This is a degree, remember that's like x to the 1, so it's a degree 1. So we need to change it so that there's one with the degree 5 first. It is a positive, because plus 9x to the 5th power. So positive 9x to the 5th. This 4x squared is also positive. There's no negative there, so that's why we have a plus 4x squared. Minus 7x, or negative 7x, so we have a minus right here, 7x. So this is standard form because we have the highest degree first. So now what would be the leading coefficient? Well, that would be a 9. 9 is the one at the very front. 9 is in front of this term, so we call it a leading coefficient 9. Let's try B. Here we have 1, 2, 3, 4 different terms. 9y, that's like a y to the first power, so it's degree 1. 9 is alone, so it's a degree 0. 9y to the 4th, so it's a 4th power. And 5y cubed, so it's a 3rd power. So again, we need to write it so that the highest degree comes first. Because there's a minus in front of it, we do negative 9y to the 4th. It's the one that we start off with. Plus 5y to the 3rd. So again, there's the plus here, meaning this whole thing is a positive. So plus 5y cubed. The next one is this degree 1. Again, there's no sign out in front of it, so it's a positive 9, so we do a plus 9y. This one has the minus 9 or a negative 9, so we have minus 9 at the end. So this would be the standard form of this polynomial. So again, what would be the leading coefficient? What number comes out front? That would be a negative 9. Negative 9 is in front of the y to the fourth, so leading coefficient of negative 9, not just 9. Let's look at C. Again, we've got 1, 2, and 3 different terms. We've got 11b squared minus 15 plus 6b cubed. This one has a b to the second power, so it's a degree 2. 15 with no variables, so it's a degree 0. This one has b to the third power, so it is a degree 3. Moving them around, so we have the highest degree first. We need this one, the third, to be first, and there's a plus 6 here, so it's a positive 6b to the third power. This degree 2 comes next. There's no sign in front of it, so it's like a positive or a plus 11b squared. And minus 15 or negative 15 is our last piece, so minus 15 at the end. 6b cubed plus 11b squared minus 15. What would be our leading coefficient? What number comes out front? That would be 6. 6 is the leading coefficient of this piece. Again, for D, I want you to pause the video and try this one on your own. Find how many different terms there are, find the degree of each one, and rewrite it so that the highest degree term comes first. So I'll give you a second to pause it and try this one on your own. All right, now that you've tried this on your own, let's check and see how you did. We've got 1, 2, 3, 4, 5 different terms here. So in this case, we're going to have to rearrange all 5 pieces, but let's start with the degree of each. This is just w. So again, remember that's like a w to the first power because it's all alone. So that is a degree 1, just that term. 5w cubed, so that exponent gives us a degree of 3. Minus 3w squared, that exponent gives us a degree of 2. Minus 9w to the fifth, that exponent gives us a degree 5. Minus 10. 10 has no variables with it, so it's degree 0. It's just a constant term. So we need to rearrange everything so that the highest degree, this 5, comes first. Remember, because there's a minus sign here, it's negative 9w to the fifth is what we start off with. This third degree comes next, so plus, because it's a positive, plus 5w cubed minus 3w squared, because we had this negative or this minus in front of it, plus w, because this was a positive, or plus the w, minus 10, because there was the minus sign right here. I'm going to erase those, give you a better view of what that polynomial should look like. Okay, so this would be the standard form of our polynomial. Now we need to say what would be the leading coefficient, what number is out front. Again, it would be negative 9. Negative 9 is times the w to the fifth power. And that'll conclude our video.